scraping some of the crap off the deck.
Yeah, we want to get a little clean spot so we can set up our tooling and do some of our measurements. Again, you know, we're not prepping it right now for the gasket.
So are you recording all of the nefarious activities?
So one of the things to think about while we're doing this is there's a difference between accuracy and precision, right? So I'm not terribly worried about being perfectly precise. You know, I'm not gonna, take and spend an hour cleaning this block to get, a truly like ultra perfect measurement out of everything. We want to make sure there's not a major discrepancy right now that would require further investigation. Most of the measurements have about 1/1000 of an inch worth of delta between acceptable and unacceptable. Outside of acceptable would be a 1/2 thou above. So let's say that our liner protrusion here can be 1.5 to 2.5 thou, right? So as long as we're in that window, we're gonna be fine. But if we're only a 1/2 thou, then we have a problem, and now we want to really clean and triple, double check our measurements.
Gotcha.
Because now we're talking about doing machine work, But if the range is 1.5 to 2.5 and we're measuring 2 thou, plus or minus a 1/2 thou is non-critical at that point because we're still within, the accepted range. Nothing in engines are truly perfect.
A 10-letter word describing something that doesn't exist.
There's always a little bit of variance. That's why you get a range of acceptable, because at the end of the day, the engines are expanding and contracting and moving and doing quite a lot, right? They are not a static being. They're pretty dynamic when it comes to running. And
Right.
a lot of that depends on how hard they're being run. That's why in race engines, there's the old saying about loose is fast. A lot of times you'll open up clearances a little bit to allow them even more room to move around and flex without causing damage. As the crank flexes and the pistons move and the block twists, you need that clearance so everything can move and flop and twist without contacting, because you got to maintain that barrier of oil. If you tighten clearances up too much on a motor that moves a lot, then you get metal-to-metal contact and you eat an engine. So that's where race engine building is a whole nother level compared to what we're talking about here. This is a street engine, and Ferrari did a pretty good job developing it. There's not major weak points as far as dimensions and tolerances and clearances. So this is going to be an OE spec rebuild. We're not going to change tolerances and modify things. We're just going to make it fresh and new again.
You just want basically a new engine again.
Yep. I'm going to grab my profilometer, and I'm also going to grab my deck bridge and dial indicator, and we're going to do some cylinder measurements.
Sweet.
I'd like to, real quick, before he gets super technical,
Long story short, we just
I'd like to point out that he is not wearing his safety sandals today.
Oh crap, so nothing's gonna work.
I know.
High precision today, boys. I got my Adidas with the rounded heel driving shoe. Pure you see this?
You're a regular old Michael Schumacher.
Look at that. Rolled heel right there. Pure precision. So I've already gone through the shop manual, which gives us all of our dimensional specs,
Yes.
both nominal and what our wear limits are, all of that sort of thing, right? We got it printed out, but it's all in metric units. And American machine shops don't like metric units a whole lot because machine tools in America are not made in metric units.
What, is this a communist country or something? I thought this was America.
So I'd already taken the time and converted it all to inch units.
We got moon units,
Yep.
freedom units.
Yep, bald eagle nuts.
Bald eagle nuts.
It doesn't get more precise than a bald eagle nut.
Yep, nice.
So here's an idea of some of the things we're checking, right?
Bar diameter.
Yeah, overall diameter, taper, because the cylinder doesn't necessarily wear at the same rate vertically.
Okay.
And they wear more at the top than the bottom. So there are specs on how much taper is allowed.
Oh, okay.
There's also ovalization, because the outside of the cylinder is a high thrust, right? When the crankshaft is swinging around to push the piston up, it's driving the rod and the piston into that wall and then pushing it up. So the outsides of the cylinder walls
Actually get ovalized.
Yep, yep. So you want to make sure that it's not out of round and ovalized too much, as well as the liner protrusion we were talking about, and also the bore hone finish.
Okay, so there's 12 RA.
Yep.
0.00118 bald eagle nuts to 0.00314. Hey, pi bald eagle nuts.
Yeah,
Pi divided by 100, or no, 1,000 right there.
yeah. That's baby bald eagle nuts.
Tiny little infant.
What is the old joke about one red hair?
Oh no.
Oh, well, I can't say it on camera.
I've heard the term red hair. I've
Yeah,
heard it like
yeah.
one color.
Yeah, exactly.
Okay.
One red hair. So
I've never heard them add color to it.
yeah. So this is like within one bald eagle hair.
Sure that those are going to count as quacks.
Yeah, those aren't the normal quacks, but those are acceptable quacks.
Those are super quacks.
Yeah, those are double quacks. Actually, you know what? We'll give those 2 quacks each because they're so bad. All right.
So we have our range, right? So
Yep.
the smallest and largest the bore would be allowed to be for a factory piston, and then max wear would be outside of that specification,
Okay.
right? This is kind of an adventure. You're supposed to use the micrometers when you're measuring precision engine parts, but my caliper here, I really like my trusty Michitoyo. That goes down to 4 decimal points for
Full
adult.
adult eagle nuts.
So we're gonna roll this up to 3.68.
6810.
So we're actually gonna go to the larger of the 2 measurements, if my hand will.
Yeah, so don't sneeze.
Yeah, we're within 1/10 of 1,000, so that's gonna be close enough for today.
Okay.
So we're going to start with the larger spec because the bore is obviously going to enlarge in over usage and time.
Yeah.
So we're worried about it being too large. Where
Right. So if
when-
it's more than this, we know it's too big.
Exactly.
Gotcha.
And the reason why we're worried about that, right, is A, the piston will rattle in there, right, and you get excessive clearance. The rings will have less tension and things in there, which is bad for sealing, which is bad for combustion. So we want to make sure that our cylinder is not too large. I'm swinging the caliper to average it.
Yeah, it's bouncing between. Yeah.
Yeah, you're good?
Yep.
Okay. So now we're at 3.35, which is the advertised bore diameter. So see how we swing that around?
Yeah.
So according to that, we're about 5/1000ths ovalized.
Oh yeah.
See how we come up to the 5 and then it comes back?
Yep.
So that says we're about 5/1000ths of an inch ovalized. The way to confirm that and make sure there's not just a diameter measurement anomaly.
Let's move it.
Yep, we're gonna move it 90 degrees off the thrust faces. See that?
Yeah.
So our bore is more than just 3.35. So we actually have
Yeah, it's
an extra 0.002 worth of ovalization in that direction. So if we call that 0, right? So now we're 0 there. Now we come there. Yeah, we're 2 thou oval on that cylinder.
okay.
Okay, about 0 there, right? Now we spin it around. Within 1.5. So the short line is a 1/2 thou and the long line is a full thou. So that's within a 1/2 thou, so that's pretty good. Right there on 0, right?
Mm-hmm.
Okay, right there on 0.
Really good.
Looks like that one might be a 1/2 to 1 full thou. Okay.
Oop,
That's
oh,
about
2.
1 thou. Yeah. Okay. That's good there. We got 1/4 of a thou, about 1/2 thou there. So almost 1 thou. And that is cylinder, which way we're looking at block? Cylinder 3. We had, what was it, cylinder, which were the cylinders we had wonky numbers on?
So here's the compression numbers. 145, 150, 170, 165, 165, 200, 195, 180. So
Okay.
1 was really low compression.
Yeah, cylinder 1. And just looking at it, we don't have any more bore wear in cylinder 1 than any of the others. They're all
They're all
within
within 2,000s, right?
1 thou.
1,000s?
Yeah, because the short line is a 1/2 and then the full line is 1.
Oh, okay.
Yes.
okay.
So they're all within 1 thou. Wear limit is almost 2 thou.
So,
So-
we're well within, we're half of the limit.
Yep. Yeah, our bore wear is within limit. So
Nice.
that's good. Now we will try and do a roughness measurement on the cylinder walls. We'll see if this tool will do a nice job for us. Profilometer.
Whoa.
We're gonna see how this works. I haven't tried using this on one of these engines before. 52. That's still too
That's
rough.
supposed to be 3?
12.
12.
Yep.
And we're at 50.
2.
Crap. So that seems high.
Way high.
Like 4 times high. 51. So that's consistent. 139. That didn't seem happy.
And that is cylinder 7,
Yeah.
which was 195.
Yeah, that was high. 37.
Okay. And that's all on the thrust face, right?
Yeah.
So now the opposite side and see if it measures any different. 18.
That was actually pretty decent.
See?
So that's one, yeah.
Well, so that's the difference, right? This is the main thrust side of the cylinder wall, and
Yeah.
that is not. So
So it hasn't been being worn.
right. So we call this the major thrust,
Mm-hmm.
and this is the minor thrust, because the pistons do also tend to kind of get pushed to the
left and
front,
right, okay.
you know, because the float and the crankshaft and whatnot. This side, you know, really sees the least amount of wear, and there you go. There's your proof,
Yeah.
right? The factory spec is a 12 RA, right? So 12 micro inches roughness average, and we got an 18 on that side, whereas we had 100 or 50 whatever on this side, right?
Yep.
Well, we'll double check that. So now that we got a number near spec,
Near spec. Yeah, that's right. The other side, again, the thrust side. 128. Wow.
yeah. So my personal opinion would be that all of these cylinders on this bank should be replaced.
The cylinder liners.
Yep.
Because you can't redo that, right?
Right, because of the Nickel coating.
Shit.
Yeah, if these were standard steel liners, we'd bore them out oversized, rehone them, and then put oversized pistons and rings in. Yep.
Yeah.
We'll check the other side just to see. 33.
Oh, that's kind of close.
Yep.
Cylinder 1 was the lowest compression.
So see, this is why it's important to check all the things.
Yeah, this is funny.
44, 69.
Nice.
Nailed it, Adam.
And Adam just won the day.
In 80.
80. God. And what's the rate? It's 12 plus or minus what?
There is no real plus or minus.
Oh, it's just somewhere near 12.
Yeah, it just says millimeters, 0.3 millimeters. So that's it. Like that's your finish. The range on from Total Seal piston rings is like 12 to 16. Like we were saying earlier, it's a
that's
pretty narrow range. So according to that measurement, all of our cylinders
Not a
on
single
the
one was even.
on the side that counts the
Yeah,
most.
on the important side.
Yeah, if we come
Well, crap.
up here on the gravy side, we'll see how this one does. 48,
Still shit.
17. That
close
one
is
was
fine.
good. That's cylinder 2.
Yay! We actually had one.
Which is funny because cylinder 2 had like the second lowest
Second
compression.
lowest compression.
But that was on, again, that was on, you know, the least critical side. If we come back over here to,
Yeah, the other side.
yeah, the other sides,
Not being thrust very hard because it's so low.
48. And then on the minor thrust, 20.
20.
Yep, so that's on the minor thrust face. So you can see the cylinder does not wear very evenly.
No.
And you can tell when you look at it, you can see there's different shadows. Well, you guys
Yeah.
probably can't in the camera.
Can't see on the
but-
camera, but
Yeah.
yeah, I can definitely see it's got a different coloration here
Yep.
than on the bottom.
For the fun of it, as a triple check, right, we'll do the surface of the block, which we said should be between 40 and 100.
9? Wow. That's really smooth. Is that right?
I mean, you can get them that smooth. For a metal head gasket, you'd want them pretty smooth like that.
8?
It's a pretty smooth block.
Wow.
But what's funny is it doesn't seem right in the opposite way of what we're dealing with the other one.
So you said you actually wanted to be higher than that, right?
Yeah, there you go. That one was 20.
20.
Still, that's better than almost all the cylinders.
I know, right? So you're telling me the surface of this is smoother than the...
Well, yeah, because it got machined and then never. That one was 24.
24.
Yeah, it got machined and then a
The
gasket got
smashing
put on
gasket,
it,
yeah.
and then that's it. You know,
Yeah.
the cylinders you get thrashed on.
And thrusted against.
Thrusted. So much thrust.
Oh, yeah.
So that's why, we can scrape this with a razor blade and then scuff it with Scotch-Brite, and the
we're good.
surface finish will still be well within spec to keep the head gasket sealed, like in Timmy's car where we didn't bother,
Nice.
machining the motor and
Well,
all
so
that.
there's one thing we don't have to do. Hooray, we don't have to redo the deck.
Well, based on that, now we'll turn this
great.
bad boy off and we'll check all of our liner protrusions.
Great. The official reading is
Bad,
bad.
good,
Good.
and bore was also
Good.
good. At 20,000, I'd expect it to all be pretty good. Like I say, usually we just do a head job and put it
Yeah.
back together. But at 80,000, it's going to be at that, as the compression test showed, it's at that point of, if there were no problems, like if you were going to keep this car for a few years and he didn't care, could have just done a cam belt service, fixed the tune-up issues we had and run it for another few years and it won't matter. But, when you're servicing it for sale or to, and you want it in top condition, because otherwise somebody's going to be able to pick and poke at it, it's at that point of, would it be fine for a while? Sure. But is it also on that cusp of needing to be refreshed? Yes. So you either leave it alone or you do it.
Stuff going from bad to really bad.
Yeah. The only other thing I realized we didn't do was a taper check.
Oh, yeah. Okay, so you push it down and see what
Yeah.
happens.
It's pretty good. Not too bad to taper.
Looks like it's all within 1,000s.
Yeah. And we'll check it on the thrust side too. Yeah, so there you go. Here's a good example on this cylinder. See, so we're a half thou under size down at the bottom,
Yep.
and we're right on zero all the way, at
Yep.
the middle, and then you come all the way up at the very tippy top. We're oversized by half thou. So
So it's got a 1,000th variance.
yep. But see, this is actually a really good angle. You can see the scuffing on the cylinders from this angle.
Oh, wow. Yeah, there you go. You can actually see it. See the scuffing.
So again, you can just barely feel a little texture with your bare fingernail, but otherwise it's mostly just a cosmetic. That's how fine of a wear it is.
Yeah.
Yeah. So our ovalization, we can call that one good.
The taper seemed good.
Yep.
Was 1,000ths within acceptable?
Yep.
Okay.
Yeah.
Almost a
eight
thousand.
tenths. Yeah.
So-
Less than 1,000. So the taper is,
It's marginally off on one of them.
we won't say good enough. We'll call this one close
Close enough.
enough. Because at this point, we're probably going to look at replacing the liners anyway,
Right.
due to the finish on them.
Shoot,
Okay.
what sucks about the finish can't be rehoned.
Yeah, there's some guys that say if you use a diamond hone, you may be able to get the hone back, but the Nikasil coating is so thin that most machinists will say you have to take away so much material to reestablish a good hone.
It's basically like boring it over.
And you can't perfectly match the existing hone pattern. So that's the other thing. It's not just deepening the hone. You may be also,
Gouging
creating
it
a
out.
whole new pattern. So you have to go deep enough in the material to get rid of the original hone and then create a new hone.
Gotcha.
And by the time you do that, there's no Nikasil left. And the steel underneath the Nikasil isn't hardened and treated to, to be run bare. it's designed to run with the Nikasil. So you could also possibly send these cylinders out and have them re-Nikasiled, but frankly, no one gives a shit about Nikasil. The European OEMs were using it for a while to maybe increase lubricity and things, you know, reduce friction and better fuel economies and stuff like that. Maybe they last longer, but that's all irrelevant in a Ferrari motor. I mean, I've seen some Mercedes and BMW motors that have run like 300,000 miles that had, because they don't have steel liners necessarily, they're actually cast aluminum bores in the aluminum block. So then they Nikasil coat it, so it saves on cost.
Yeah,
it's
yeah.
cheaper to Nikasil coat the aluminum walls than it is to machine it and make steel liners to go in. But since it's fine. Race motors don't use Nikasil liners. They have steel liners with good rings in them. So, you know, that's why we would just get rid of the Nikasil liners and put standard steel liners in it and be done with it. All right, so now we're going to check our liner protrusion, which is between 1/1000 and 3/1000. Yeah,
okay.
so it's a pretty, like I said, that's a pretty
Very
big,
small.
yeah, pretty big range. Let's make sure we don't have, because it looks like maybe we've got
Oh, there's a
some.
little bit of crap on it. Yeah. Definitely some shit on it.
Still quite a bit.
Still 5 or 6.
Yep.
5.5. 5.
So we'll double check our book and see.
7.
Oh, this one's millimeter.
Oh.
So that was 0.05 millimeters.
So no bald eagle nuts measurement on that one.
I grabbed my my dial indicator from my Hill Engineering TDC kit, and it's in millimeters, not in bald eagle nuts. So in metric, it is 0.03 to 0.08 millimeters.
Oh.
So
Yeah.
then those are actually good.
They're actually
Yep.
in spec.
Yeah, I'm gonna say those are way too far off. You know, like 1 thou, half a thou makes sense, but not like 4 or 5. So
When something doesn't seem right,
yeah.
double
right.
check.
So yeah, so that's 5, right?
Yeah.
That's 5.
Yep.
This has got gunk on it, but
Still 5.
still 5,
7.
7.
Still
Okay.
within spec though.
Yep. But now we did that. Now you want to cross check it.
The other side.
Yep, and make sure that the cylinder is not
Yep.
cocked.
Yep.
Yep. So that's 7.
Which was the same.
Yep. So yeah, that's 5. Yep. About 5. About 7.
Okay.
So yeah. So
Nice.
we got proper protrusion, no obvious signs of the cylinders having come loose, and you know the register in the bottom of the block being off. So as far as we can tell, aside from the cylinder wall wear, the rest of it measures okay. We'd probably have a very difficult time getting the new piston rings to seat properly. That'd probably be the worst thing that would happen, because that means either the motor smokes and still has bad compression through the rings forever, and you have to take the whole motor back apart to do it right, or maybe you get lucky and you don't. This is not a pickup truck motor where it's very easy to take out and take apart, so we don't want to deal with that if we don't have to. So that's a quick rundown on basic cylinder checks that we can do in the shop before deciding whether or not it needs machine work and
Nice.
more parts.
Okay, so from the looks of it, we probably need to get new cylinder liners. So I'm gonna talk to the owner and make sure he's cool with that. Otherwise, the rest of the blocks seem okay. So what we're gonna do in the next video is we're gonna check on the main bearings, and then we still have to check on the heads and the rod bearings, right?
Yep.
So those are the still remaining checks. So the heads, we have to do the valve guides, the valve stuff.
Yep.
Once we get all of these checks done, we're gonna send this off to get to the machine shop. We'll send the heads off to the machine shop. They'll come back in, I'm assuming, in a couple weeks, and then we'll start assembling, basically, at that point, a brand new engine. It's gonna be
Yeah.
awesome. I can't wait to see this thing running and see how good it is. And of course, once we get it all done, we'll do like a compression check and show you what it looks like once it's like, I guess we have to break it in first though, right?
Yeah, we gotta put some miles on it and get it all broken in.
All right, guys, so that's what we're gonna do in the next video. So definitely wanna like, share, and subscribe, because that's what's coming your way. If you want Josh's help, please go to exotic-power.com. Keep thinking of the old website. It's a new website, exotic-power.com. You can hire Josh's services. And of course, if you need any of our help, go to normalguysupercar.com, and there you can use the code NGS10 to hook you up with 10% off almost everything we sell. And then finally, all the parts that we're using have been sponsored by Ricambi America, so go check out ricambiamerica.com. You can use the code NGS10 and orders over $100 and it knocks off 10%. So do those things, save yourselves a little bit of money. And you know the deal, we're gonna be doing a lot more car stuff, so you're gonna wanna stay tuned.
It's gonna be sweet.
Hey, got the background help.